You know, we hear all the time that AI is changing the world. But deep in the hidden realm of cybersecurity, it's not just changing the game, it's basically starting an arms race. And we're not just talking about smarter tools. This is a fundamental shift in the very nature of digital conflict itself. The battlefield is everywhere, and the rules have changed forever.
And this quote right here, it just nails the central idea perfectly. The entire battlefield has shifted from human speed to machine speed. And that's way more than just a simple upgrade in velocity, you know? It means the old rulebook for how you attack and how you defend, well, you can pretty much just throw it out the window. The very physics of this fight have been rewritten.
So, what does that actually look like? Well, check this out. On the left, you've got the old way of doing things, a person, an analyst, manually scripting, limited by how fast they can think and type. But on the right, that's the new reality. We're talking autonomous AI agents that can adapt in milliseconds and hit thousands of targets at once. This isn't just setting the stage for an arms race. I mean, let's be real, the race has already started.
Okay, so let's look at the first side of this conflict, the offense. What's happening is that AI is essentially democratizing hacking. Yeah, really. These super sophisticated attacks that once required the kind of resources only a nation-state could afford, now they can be pulled off by folks with way less experience, all because they have access to these powerful AI tools.
A perfect example of this is AI-driven polymorphic malware. Now, this isn't just some smarter virus. Think of it more like a shapeshifter. It's literally designed to be a moving target, rewriting its own code every single time it infects a new machine. And that makes traditional antivirus software, which is looking for a specific digital fingerprint, almost completely useless. I mean, how do you possibly catch a criminal who can change their identity every single second?
And this table really just lays out the stark difference. Look at this. The speed goes from manual to practically instant. The skill required, it plummets. You don't have to be a coding genius anymore. You just have to be good at telling an AI what you want it to do. And the cost? It drops from needing these super expensive human experts to just needing access to an AI model. So the bottom line is brutally simple. Attacks are now faster, they're cheaper, and they're way easier to launch than ever before.
But of course, this isn't a one-sided fight. For every new weapon, a new shield gets forged, right? So defenders are using the exact same AI technology to build what you could call digital sentinels, smarter, faster, and more resilient security systems designed to fight back. So modern AI defense is really built on three main pillars. First, you've got proactive, automated hygiene. Just think of it like an AI that is tirelessly checking all the locks and windows, patching vulnerabilities before attackers even know they exist. Next up is the brain of the operation, anomaly detection. And finally, you've got the muscle, autonomous response, which is where the AI instantly neutralizes a threat, often before a human being even gets an alert that there was a problem. Let's focus on anomaly detection for a second, because this is a total game changer. Instead of just relying on a big list of known viruses, the AI builds this deep, nuanced understanding of what's normal for your network. You know, who logs in and when, what data is usually accessed, how much traffic is flowing. Then it just watches for anything that breaks from that pattern. It's not looking for a known criminal. It's spotting anyone who's acting suspiciously. And the accuracy of these systems? It's pretty astounding. As this chart shows, a single AI model on its own is already impressive, catching threats about 85% of the time. But when you create what's called an ensemble, basically a team of different AIs that all get a vote on whether something is a threat, the accuracy just skyrockets. It's like that old saying, 2 heads are better than 1. Except here, it's a whole committee of AI experts making the defense nearly impenetrable.
So, okay, we've got this escalating arms race between offensive AI and defensive AI. But here's where it gets really interesting. Here's the critical twist. What if the most effective way to attack isn't to try to sneak past the defensive AI, but to attack the AI itself? To turn the defender's greatest strength into its absolute biggest vulnerability? And this is the question that just flips the entire game on its head. What happens if the AI guardian is actually the weak link? Because if you can poison its mind, you don't have to worry about sneaking past the gates. You can just trick it into opening the front door and welcoming you right inside. This leads us straight to the #1 threat for AI systems today. It's called prompt injection, and you should think of it less like a bug and more like a fundamental design flaw in the AI's brain. See, an AI can't always tell the difference between its original programming and new instructions that it gets from a user. So a clever attacker can inject a hidden command into what looks like normal data and trick the AI into following new orders. It's like whispering a secret command to a guard dog that makes it suddenly see you as its new master. And listen, this isn't just some science fiction theory.
A real-world critical vulnerability was found in GitHub Copilot, which is the AI coding assistant used by millions of developers around the world. Through a really sophisticated prompt injection, an attacker could trick Copilot into running malicious code on a developer's computer. The very AI tool designed to help you write code could be turned into a weapon against you.
And the danger was absolutely extreme. On the industry standard severity scale, this vulnerability scored a 9.6 out of 10. To put that in perspective, that is a 5-alarm fire. That signifies a critical flaw that is both easy for an attacker to exploit and has a potentially catastrophic impact. It just underscores how serious this new threat of attacking the AI itself really is.
So all of this brings us to the inevitable question. Where does this escalating arms race even go from here? We've seen the offense, we've seen the defense, and now we've seen the attacks on the defenders themselves. What is the logical conclusion of all this autonomous conflict? This timeline really shows you just how fast the ground is shifting under our feet. I mean, just a short while ago, AI was simply a tool to assist humans. Right now, in 2025, it enhances our work, automating complex things while we kind of keep an eye on it. But the destination? It's crystal clear. A future that is fully agentic. A future where autonomous AI agents fight entire campaigns on both sides, making strategic decisions in milliseconds, with humans pushed completely out of the loop. And that leads us to the ultimate question. And it's not a question of technology, really, but of humanity. When the battle is being waged at a speed that no human can possibly follow, what is our role? In an age of truly autonomous conflict, where does human judgment fit in? Does it even fit in at all?
Okay, let's dive into the new era of cyber conflict, one that's being fought entirely by artificial intelligence.
You see, the whole battlefield has changed. It's no longer fought at human speed, but at machine speed. Just look at this table. The shift is just dramatic. AI makes hacking way faster, easier, and much harder to spot. So, who has the ultimate weapon in this fight? Well, it's tricky because AI is both the weapon and the shield. First up, the offense. Let's see how AI has basically become the ultimate tool for any attacker. The number one risk here? It's called prompt injection. You're basically tricking an AI into breaking its own safety rules. And get this, it really happened. The grandma exploit tricked ChatGPT into giving up actual Windows license keys. Wild. But it goes way beyond just tricking a chatbot. Now, AI is actually being used to create its own malware. This process creates what's called polymorphic malware. It's constantly changing, so traditional antivirus software just can't keep up. And we're also seeing autonomous agents that can plan and execute entire cyber attacks all by themselves.
Okay, so that's the scary part. Let's flip to the other side of the coin. AI as the sentinel.
See, instead of just looking for known viruses, AI learns what's normal for a system and flags anything that isn't. So what kind of unusual stuff can it actually find? Well, AI is trained to look for 3 key anomalies. First is a point anomaly. Think of a single data point that is just completely, obviously out of place. Then you have a contextual anomaly. The action itself is fine, but the when or where is super suspicious.
And finally, a collective anomaly. This is when a bunch of normal-looking events together actually spell big trouble.
And by layering multiple AI models together, these defensive systems get way more accurate at spotting threats. So what does this all create? An escalating cyber arms race, a constant back and forth between attackers and defenders. And the scale here is just massive. We're talking about a projected $93 billion in AI security by 2030. And looking ahead, things get even crazier. We'll have to deal with stuff like shadow agents and deepfake identity threats. Which leaves us with one huge, critical question. In a war that's fought entirely by AI, where do humans fit in?